Hey, I'm John Wall. I'm here to show you what image classification techniques used in ArcGIS Pro can offer on an aerial image that could potentially allow researchers to conduct plant counts a lot quicker than they could just by walking the field with a pen and paper. Specifically, we'll look at corn emergence, and there's a lot of reasons why it's important to look at uniformity of emergence, but we won't get into those. So I'll use an aerial image as a TIFF file from one of my flights during one of the first 4 to 5 days of emergence. And so I'll add a TIFF file into my catalog pane by connecting a folder in ArcGIS Pro. And then I'll add that into a blank map. So here I'll zoom down and show you the corn spikes, and this is emergence. This is day 3. Just from this aerial image, we can see that the corn is about 29 pixels per plant. And these are what we're after, is to be able to tell the computer what's a plant and what's soil. So I want to run through 3 different classification techniques for comparison and show you the output and discuss them. So supervised image classification will be first, and then we'll talk about object-based image classification or analysis, that's OBIA, and then we'll finish off with binary thresholding and false NDVI. Here's my supervised image classification. I use a support vector machine algorithm, and I've got 4 classifications for my training samples manager. Split it up: soil, corn, black, and white. I'll end up adding T's later because I put out T's, and this one I didn't see it until I zoomed in. And I'll define about 200 polygons for soil, just under 100 for corn, and then maybe 20 or 30 for black and white. Here are the steps for supervised image classification. It's very simple, and here I am training it. You can see what I zoom in, and I'll draw around maybe 20 or 30 pixels there for corn. And here's my result. This is using support vector machine, and you can clearly see the rows of plants. We get a lot of noise because we can't define size, so I can't set a minimum or maximum size for plants, and that's why I'll move on. And I want to show you attempt 2 and attempt 3 there. I'm using ISO cluster still. Just you can see the rows, you can see the plants, but we want to get a little better than that. And this final slide on supervised image class shows you how accurate it was. Next, I want to talk about object-based image analysis. This lets me define a size for my plant counts. Here's the preview of the OBIA running in my little error code that I get when I define too small of a value for plant clusters, or for pixel clusters. So here I use segment mean shift just to get across the point that I can use OBIA to define pixel values, pixel clusters, and this is using 50 as a minimum pixel cluster, and like I said, my plants were around 20 to 40, so they don't show up, but this shows me that OBIA has a lot of potential here, because it can define them really well. This looks really good. And as image resolution gets better, so will this OBIA classification. And here it is for comparison. Lastly, I used binary thresholding technique in order to create a false NDVI. This partitions the image into the foreground and background. It's a really quick, easy type of image segmentation that'll isolate the plants out from the soil. So you can see clearly in my output on the top left that the image partitioning did its job. You can clearly see the boundaries of the plant and the soil, and this will allow me to hone in on the value of each pixel of each plant, define those, and separate those out from the soil. Combining all of these techniques could show a lot of potential. I really like the OBIA classification. I think that as image resolution gets a little better, so will this. Here's some references, and thank you so much for watching. I hope you enjoyed it as much as I did.